Welcome dear students. Let us start with today's video. Subject Geometry, Standard 10th, Chapter 6th, Topic Trigonometry, Module 6th. Let us continue with the chapter of Trigonometry in this video. Let us see the objectives of this video. So we are going to revise the application of trigonometry, the concepts in this application of trigonometry which we are going to revise are line of vision, angle of elevation, angle of depression, and we are going to solve the sums from practice set 6.2. Let us recall the formulas that we have seen in our last videos. So we had seen the trigonometric ratios. First is cot theta is equal to adjacent side upon opposite side. Cosec theta is equal to hypotenuse upon opposite side. Sec theta is equal to hypotenuse upon adjacent side. Next we had seen about the relation between trigonometric ratios. So first is cosec theta into sin theta is equal to 1. Sec theta into cos theta is equal to 1. Cot theta into tan theta is equal to 1. Also we had seen the formula of cot theta, that is cos theta upon sin theta. Next we did trigonometric identities or the trigonometric equations. So the three trigonometric equations which we have seen are sin square theta plus cos square theta is equal to 1. 1 plus cot square theta is equal to cosec square theta. 1 plus tan square theta is equal to sec square theta. Now let us see the concept of application of trigonometry. We have already seen some based on the application of trigonometry, and also we have seen certain concepts based on application of trigonometry. Let us revise these concepts over here as well. Let us learn some concepts before studying application of trigonometry. We have already seen these concepts in previous videos. Now let us revise it once more. So suppose there is a person who is looking at the building. If there is an object situated at point B, then from the observer, that is from the point A, there is a straight line that forms. That line is called as line of vision. So line of vision is basically the line which forms between the observer and the object. So if the observer is standing at location A, looking at an object at B, then line AB is called as line of vision. Now here in this picture, you can see that there is a person standing in front of a building. Wherever the object might be on the top of the building or at some floor or below, wherever the object might be, still when a person he looks at that object, but the one line that forms from the eye of the observer, the line that goes straight is nothing but horizontal line of vision, or also called as horizontal line. Now suppose the person is standing on the ground and he is looking at an object which is on the top of the building. So first of all, this will be the horizontal line. The line that goes straight is a horizontal line. Now when he is looking at an object situated upwards, so between the object and the observer or the person, the line that forms is line of vision. So between line of vision and horizontal line, there forms an angle over here. So this angle is nothing but angle of elevation. So angle of elevation is formed when we see above the horizontal line. So the definition of angle of elevation is if the observer at A observes the point B which is at a level higher than A and AM is a horizontal line, then angle BAM is called as angle of elevation. Now suppose here the person is standing on the top of the building and he is looking at an object situated down or on the ground. So first of all, this is horizontal line. The line that goes straight is a horizontal line. But when he is looking down at an object, the line that forms between the object and the person or the observer is called as line of vision. So between the horizontal line and line of vision, there forms an angle. That angle is called as angle of depression. So basically, angle of depression is formed when the person is looking below the horizontal line. The definition of angle of depression is if the observer at A observes the point C which is at a level lower than A and AM is horizontal line, then angle MAC is called as angle of depression. So now we had seen or we have revised the concepts on application of trigonometry. Now let us move forward to the problems based on the application of trigonometry. Some problems we have already seen in our previous videos. Now the remaining sums we will do here. Now let us see practice set 6.2 question number 1. So the first question says, a person is standing at a distance of 80 meters from a church looking at its top. The angle of elevation is of 45 degrees. Find the height of the church. So the person is standing at some distance away from the church which is 80 meters and he is looking at the top of the church, which means he is making an angle of elevation which is 45 degrees. So we need to find out the height of the church. So solution, let us formulate this sum in the form of diagram. So AB is equal to height of the church, CB or BC is equal to 80 meters which is distance of the observer from the church. So let us join AC. AC is nothing but line of vision. So if C is the position of the observer and A is the position of an object, so from the observer till the object, there forms a line which is nothing but line of vision. So AC is nothing but line of vision. BC is nothing but horizontal line over here. So between the line of vision and horizontal line, there forms an angle which is nothing but angle of elevation. But angle of elevation is formed when a person is looking at a level lower, at a level higher. So angle ACB is nothing but angle of elevation which is 45 degrees. Now let us use the tan ratio as we have adjacent side and we need to find out the opposite side in this triangle. So therefore tan theta is equal to AB upon BC. Let us consider this as equation 1. Now the value of theta is 45 degrees. So we have tan 45 degrees is equal to 1 from the table. So let us consider this equation as 2. So comparing equation 1 and 2, we get AB upon CB is equal to 1. Let us substitute the value of CB over here. So the value of CB is nothing but 80. So therefore we get AP is equal to 80 which is equal to CB. So hence AB is what? 80 meters. AB is nothing but height of the church. So we get the height of the church as 80 meters. Now let us see the second question. From the top of the lighthouse, an observer looking at the ship makes angle of depression of 60 degrees. If the height of the lighthouse is 90 meters, then find how far the ship is from the lighthouse. And also they have given us the value of root 3 as 1.73. Solution. Now suppose AB is the height of the lighthouse which is given as 90 meters. Let us first draw the diagram. So AB is 90 meters, which is height of the lighthouse. Let C represents the ship and A is the position of the observer. So C is nothing but ship. So let us join BC. AC is nothing but angle of line of vision. And AM is nothing but horizontal line. So between line of vision and horizontal line, there is an angle which is called as angle of depression. So angle MAC is angle of depression. Now we know that angle MAC and angle ACB are both alternate angles. So by alternate angles theorem, angle MAC is equal to angle ACB. So if angle MAC is 60 degrees, then angle ACB will be also 60 degrees. Now let us consider a triangle A, B and C. So in this triangle ABC, angle ABC is 90 degrees. So we can use trigonometric ratios. So here we are going to use tan ratio because opposite side is given and we need to find the adjacent side, which is opposite side is nothing but height of the lighthouse is given and we need to find the distance of the ship from the lighthouse. So we need to find the value of BC. So in order to find the adjacent side, we are going to use tan ratio. So tan of angle ACB is equal to adjacent, opposite upon adjacent, which is equal to AB upon BC. So tan 60 degrees is equal to AB upon BC. Tan 60 degree we already know from the table, which is root 3, which is equal to value of AB is 90 upon BC. So therefore BC is equal to 90 upon root 3. Now let us multiply root 3 in numerator and denominator both. So we get 90 into root 3 upon root 3 into root 3, which is equal to 90 into root 3 upon, in the denominator when we multiply root 3 into root 3 we get it as 3, which is equal to 30 root 3, which is equal to 30 into 1.73, which is given in the question, the value of root 3 as 1.73. So when we multiply it, we get the distance of the ship from the lighthouse, which is 51.90. So the distance of the ship from the lighthouse is 51.90 meters. Two buildings are facing each other on a road of width 12 meter. From the top of the first building, which is 10 meter high, the angle of elevation of the top of the second is found to be 60 degrees. What is the height of the second building? So suppose, let us consider the two buildings as this building, which is AB, which is 10 meters, and the second building as CD. So we need to find the height of the second building, which is CD. Also the width of the road is given, that is 12 meter. So suppose BD is the width of the road, which is 12 meter. AB is nothing but horizontal line. AE is nothing but horizontal line. So from the top of the first building, an angle of elevation is made to the top of the second building, which is 60 degrees. So from A, there is a line of vision to C. So AC is line of vision. So angle ACE is 60 degrees, which is angle of elevation. AB and CD represents the height of the two buildings on the either side of the road. AB is 10 meters, BD is 12 meters. Angle CAE is angle of elevation. So angle CAE is equal to 60 degrees. So here forms a quadrilateral ABDE. So the quadrilateral ABDE is a rectangle, which is by definition. So if it is rectangle, then its opposite sides are equal. So AB is equal to DE, which is 10 meters, and AE is equal to BD, which is 12 meters. Now let us consider the triangle. So in triangle AEC, angle AEC is 90 degrees. So therefore, tan of angle CAE is equal to CE upon AE. Therefore, tan of 60 degrees is equal to CE upon 12. Therefore, tan of 60 degrees is nothing but root 3, which is equal to CE upon 12. So therefore, CE is equal to 12 root 3. So we get the value of CE. Now we want to find out the value of DE, so that we can find out the entire height of the building, which is DC. So now we know that CD is equal to CE plus DE. The value of CE we have found out, which is 12 root 3, and the value of DE also we know, which is equal to AB, which is 10 meters. So therefore, adding 12 root 3 plus 10, we get the height of the second building. So therefore, the height of the second building is 12 root 3 plus 10 meters. Now let us see the fourth question. Two poles of height 18 meter and 7 meter are erected on a ground. The length of the wire fastened at their tops is 22 meter. Find the angle made by the wire with the horizontal. So we need to find the angle made by the wire with the horizontal or the ground. So let us see the solution. Suppose AB and CD represents the height of two poles. AC is the length of the wire of length 22 meter joining the top of A and C of two poles. Suppose AC is equal to 22 meter. Angle ACE is the angle made by the wire with the horizontal. So this angle we need to find out. We need to find the angle made by the wire with the horizontal. So here that angle is angle AC and E. Angle ACE. So now as you can see in this diagram, quadrilateral EBDC is a rectangle, which is by definition. So you can see that BE is equal to CD. So CD, we have the value of CD, we already know, that is 7 meters. So BE will also be 7 meters. They are equal because they are opposite sides of rectangle. So opposite sides of rectangle are always equal. Now, in order to find out AB, we know that AB is equal to AE plus BE because points A, E and B are collinear. Value of AB we already know, which is 18, which is equal to AE plus value of BE we also know, that is 7. So therefore, by subtracting 18 minus 7, we get the value of AE. So therefore, AE is equal to 11 meter. Now let us consider triangle AEC. So in triangle AEC, angle AEC is equal to 90 degrees. So therefore, we need to find out angle ACE. We already have the value of AC and we already have the value of AE as well. So we can use sine ratio because we have hypotenuse side and opposite side. So the trigonometric ratio which is related to opposite and hypotenuse side is sine ratio. So we are going to find out sine of angle ACE, which is equal to opposite upon adjacent, which is equal to AE upon AC. So substituting the values of AE and AC over here, we get, therefore sine of angle ACE is equal to 11 upon 22. So therefore sine of angle ACE is equal to 1 upon 2. But we know that Sine of 30 degrees is equal to 1 upon 2 from the table. So by equating both these values, we get sine of angle ACE is equal to sine of 30 degrees. So therefore angle ACE is equal to 30 degree. So hence the angle made by the wire with the horizontal is nothing but 30 degrees. Now let us see the fifth question. A storm broke a tree and a treetop rested 20 meters from the base of a tree, making an angle of 60 degrees with the horizontal. Find the height of the tree. So again this is similar to the sum which we have seen in the previous video. So let us solve this sum. First of all, let us formulate this sum in the form of diagram. So here the tree was standing, let it be AB. It broke at point C and it stopped, rested or touched the ground at point D. Now the distance of the tree from the base to the top where it touched is given, that is 20 meters. Now the tree was standing perpendicular to the ground. So here it forms a triangle BCD. Also they have given that the tree when it touched the ground, it stopped, made an angle of 60 degrees with the ground. So we need to find the height of the tree here. So suppose AB is the tree, it was broken at C and it stopped touched at D. Angle CDB is equal to 60 degrees, BD is equal to 20 meters and CA is equal to CD. So in right angle triangle CDB, tan 60 degrees is equal to opposite upon adjacent, which is equal to BC upon BD. So here we need to find the height of the tree, that is AB. So in order to find the value of AB, we will find out first BC and then we will find out AC. After that we will add both the values, we will get the value AB. So therefore tan 60 degrees we already know, that is root 3. BD we already know, that is 20. So substituting all those values here, we will get, therefore root 3 is equal to BC upon 20. So therefore BC is equal to 20 root 3. Now we have the value of BC, we are going to find out the value of AC. So now we know that AC is equal to CD. So if we find out the value of CD, we can get the value, we will be getting the value of AC only. So in order to find the value of DC, we are going to use another trigonometric ratio. So here I have used cos 60 degrees, which is equal to BD upon DC. That is cos theta is adjacent upon hypotenuse, which is BD upon DC here. Now we have the value of BD and we have the value of cos 60 degrees, which is 1 upon 2. So substituting all those values over here, we will get, therefore 1 upon 2 is equal to 20 upon DC. Therefore DC is equal to 20 into 2. Therefore DC is equal to 40. So we have the value of DC. So DC is nothing but AC. So substituting AC and BC over here, we will get the value of AB. So therefore AB is equal to AC plus BC, which is equal to 40 plus 20 root 3. Therefore the height of the tree was 40 plus 20 root 3 meters. Now let us see the last sum. A kite is flying at a height of 60 meters above the ground. The string attached to the kite is tied at the ground. It makes an angle of 60 degrees with the ground. Assuming that the string is straight, find the length of the string. Also in the bracket they have given the value of root 3 is equal to 1.73. So we need to find out the length of the string. So here you can see the diagram. Let us formulate this diagram. K is the position of the kite in the sky, suppose, which is 60 meters above the ground level. So Km is equal to 60 meters. Suppose kg represent the length of the string, which we have to find out. Angle made with the ground and string is equal to angle KGM, which is 60 degrees. So we have opposite side and we need to find out the hypotenuse side. So we are going to use trigonometric ratio of sine. Sine of angle KGM is equal to opposite upon hypotenuse, which is equal to Km upon Kg. So sine of 60 degrees is equal to Km upon Kg. Sine of 60 we already know from the table, which is root 3 upon 2. Value of Km is given, which is 60 upon Kg. So therefore Kg is equal to 60 into 2 upon root 3. Now we have seen in the previous videos as well that in the denominator we do not keep root 3. So in order to eliminate root 3 from the denominator, we multiply root 3 in the numerator and denominator both. So therefore we get Kg is equal to 120 into root 3 upon root 3 into root 3. So therefore Kg is equal to 120 into root 3 upon 3. So therefore Kg is equal to 40 root 3. The value of root 3 is already given in the question, which is 1.73. So substituting that value over here, we get therefore Kg is equal to 40 into 1.73, which is equal to 69.20 meters. So therefore the length of the string is equal to 69.20 meters. So I hope you all have understood today's video. The next sums we will be solving in our next lecture. Thank you.